If we ever want to really live out there among the stars, we've got to solve one of our oldest challenges in a place that is completely alien. We have to learn how to farm. So in this explainer, we're going to dive deep into the incredible science of growing plants off-world. Here's how we're going to break it down. First, we'll ask the big question. Why even bother farming in space? Then, we'll face the brutal reality of the void. We'll tackle the massive problem of scarcity, and finally, we'll look at the absolutely brilliant solution, the autonomous greenhouse. So why not just, pack a few centuries worth of dehydrated meals? Well, because when you're talking about living on the moon or Mars long term, being self-sufficient isn't just a nice to have, it's literally the only way to survive. And that gets us right to the heart of the problem. I mean, think about it. Everything a plant has evolved over billions of years to depend on, gravity, a stable climate, a protective atmosphere, it's all gone. So where do you even start? It really just boils down to this. Farming in space isn't just about calories. It's about creating a tiny, sustainable bubble of Earth far from home. It provides food, sure, but also oxygen, clean water, and a huge psychological boost for the crew. It's the key that unlocks the rest of the solar system. All right, let's get into our first massive challenge, the environment itself. Space isn't just empty, it's actively trying to kill things. And the first hurdle is something we never ever think about on Earth, gravity. See, here on Earth, gravity is like a compass for plants. It tells the roots which way is down to find water and nutrients, and tells the shoots which way is up to find light. But in microgravity, that compass is just broken. The plants get totally confused, which leads to stressed, chaotic, and really inefficient growth. Now, what's actually going on here is a biological process called gravitropism. Inside a plant's cells, there are these tiny, dense starch granules that settle downwards, kind of like sand in a jar. That's the signal for down. But without gravity, they just float around. The plant has no idea which way is up, and it's effectively lost. And the lack of gravity creates even weirder, more counterintuitive problems. For instance, warm air doesn't rise. So a plant can actually create a little bubble of its own waste gas around its leaves and literally choke itself. And get this, water doesn't drain away, it clings to the roots in a thick film, drowning them. It's a bizarre paradox where the roots can be suffocating in water and starved of oxygen at the same time. Okay, so beyond gravity, there's this constant, invisible threat. One of our sources had this fantastic way of putting it. Space radiation is like micro-artillery. Without Earth's magnetic field and thick atmosphere, plants and people are just getting pummeled by high-energy particles that shred their DNA. And this bombardment really comes in two main flavors. You've got galactic cosmic rays coming from distant supernovae. These things are super high energy and incredibly hard to stop. And then you have solar particle events, which are these sudden, intense bursts of radiation from our own sun. Both can be lethal to crops, which means heavy shielding is non-negotiable. But here's the cool part. Being stuck in a sealed environment isn't all bad. In fact, it gives you a superpower. On Earth, CO2 levels are about 420 parts per million. In a space greenhouse, you can crank that dial way up to around 1500 ppm and basically supercharge photosynthesis and get way bigger harvests. Of course, there's a catch. There's always a catch, right? In that sealed room, plants also release a stress hormone called ethylene. If you let that gas build up, it can cause a chain reaction, making the entire crop ripen, age, and rot way too fast. So you need sophisticated air scrubbers running 24/7 just to keep things in balance. So let's say you figured out how to survive the environment. Now you run headfirst into the next impossible problem, building a farm with almost nothing. Every single gram of water, every nutrient, every watt of power is unbelievably precious. And you might be thinking, well, why not just use the Martian soil? The simple answer is, it's not soil. It's what we call regolith, and it's nasty stuff. It's a toxic, chemically reactive dust full of chemicals called perchlorites. It's abrasive like crushed glass, and it has zero organic material. You can't just plant a potato in it and hope for the best. And look at this number. Up to a full % of the Martian regolith is made of these toxic perchlorates. Now, 1% might not sound like a lot, but trust me, it's more than enough to poison the plants and any human who might eat them. Getting rid of it is a huge challenge. To even try to make it usable, you'd have to use massive amounts of water, which is basically the most precious resource you have in space, just to wash the toxins out. That's a non-starter. And that's exactly why most of the research is focused on soilless methods, like hydroponics, to just bypass the problem entirely. All of this brings us to the ultimate dream, the holy grail of living in space, what's called a bioregenerative life support system. Just think of it as a perfect closed-loop ecosystem where absolutely nothing is wasted. The farm literally becomes the lungs, the kidneys, and the pantry for the entire habitat. And this chart illustrates that idea perfectly. It's a circle of life. The plants take human waste and the CO2 we breathe out and turn it into fresh oxygen. They suck up dirty water and release pure, clean water vapor through transpiration. And then the waste from the plants themselves gets recycled back into nutrients. It's the ultimate recycling program. Okay, so we've got a hostile environment and basically no resources. How do you possibly make this work? The solution is in our final section. You take the human out of the equation as much as possible, and you build a truly intelligent, automated farm. Astronauts are highly trained scientists and explorers, not full-time farmers. Their time is way too valuable. That's why every single component of a space greenhouse is designed around this one critical principle: mean time between failure. Every pump, every light, every sensor has to be built to work flawlessly for years on end with zero human intervention. This means the farm has to be run by an AI. We're talking about a system that handles everything, from robotic arms planting seeds and harvesting crops to constantly monitoring the air and water. And with tools like hyperspectral cameras, the AI can actually see the light reflecting off leaves and spot signs of stress or disease days before a human ever could. This isn't just farming, it's preemptive farming. And that is really the most crucial point to take away from all of this. We have to stop thinking about this as a quaint little garden in space. It's not. It's a machine for living. It is one of the most complex, automated, and vital pieces of technology we will ever have to build if we're serious about becoming a multiplanetary species. Which leaves us with one last, really fascinating thought to chew on. If we're developing these incredible technologies to sustain life in the most hostile place we can imagine, what problems could that same technology help us solve right here, back on Earth?